What if I told you there's an object so powerful that it can literally rip apart stars, bend time itself, and trap light forever? Black holes are the most extreme objects in our universe, and today we're diving deep into what makes them so terrifying and fascinating. But here's the real question. Everyone wants answered. Could a black hole actually destroy Earth? Stick around, because the answer might surprise you. So let's start with the basics. A black hole is a region in space where gravity is so incredibly strong that nothing, not even light, can escape once it crosses a point called the event horizon. Think of it like a cosmic drain where space-time itself gets sucked in. But here's what most people don't realize. Black holes aren't cosmic vacuum cleaners roaming around devouring everything. They're actually formed when massive stars, usually at least 20 times the mass of our sun, run out of fuel and collapse in on themselves in a supernova explosion. All that mass gets compressed into an infinitely small point called a singularity. And here's the mind-blowing part. If you could replace our sun with a black hole of the same mass right now, Earth wouldn't get sucked in. We'd just keep orbiting like normal, just in eternal darkness. The gravity would be exactly the same, because the mass is the same. It's only when you get really close to a black hole that things get absolutely wild. Let's talk about what actually happens near a black hole, because this is where physics gets absolutely insane. First up, temperature. You might think black holes are cold since they trap light, but the area around them can reach temperatures of billions of degrees. As matter spirals into a black hole, it forms what's called an accretion disk, spinning faster and faster, creating friction that heats the material to unbelievable temperatures. We're talking hotter than the core of any star. This superheated material releases intense X-rays and gamma rays that we can actually detect from Earth. Now, storms. The regions around supermassive black holes at the centers of galaxies experience the most violent conditions imaginable. Powerful jets of particles shoot out from the poles at nearly the speed of light, spanning thousands of light years. These cosmic storms of radiation and matter would instantly vaporize anything in their path. But gravity, that's where things get truly weird. Near a black hole, you'd experience something called spaghettification. Yes, that's the actual scientific term. The gravitational pull on your feet would be so much stronger than on your head that you'd literally be stretched into a long, thin strand like a piece of spaghetti. This happens because of tidal forces, the difference in gravitational pull across your body. Here's something that completely breaks our understanding of reality. Time near a black hole doesn't work the same way. According to Einstein's theory of relativity, the closer you get to a black hole, the slower time moves relative to someone far away. If you watched your friend fall toward a black hole's event horizon, you'd see them move slower and slower, their image getting redder and dimmer until they appear frozen at the edge forever. But from their perspective, they'd cross the event horizon in finite time and wouldn't even notice anything special about that moment. They just keep falling toward the singularity, where physics as we know it breaks down completely. And once you cross that event horizon, there's no coming back. Not with rockets, not with anything. You'd need to travel faster than light to escape, which is impossible according to everything we know about physics. Not all black holes are created equal. There are actually several types, and understanding them is key to answering our big question. Stellar black holes form from collapsed stars and typically range from about 5 to 100 times the mass of our sun. Scientists estimate there could be 100 million of these scattered throughout our Milky Way galaxy alone. Then there are supermassive black holes, absolute monsters that sit at the centers of most galaxies, including ours. Our galaxy's supermassive black hole, Sagittarius A star, weighs about 4 million times the mass of the Sun. But some supermassive black holes are billions of times more massive than our Sun. There are also intermediate black holes, which fall between stellar and supermassive, and theoretically primordial black holes that could have formed in the early universe, potentially as small as an atom but with the mass of a mountain. Okay, here's the moment you've been waiting for. Could a black hole actually destroy Earth? The short answer is, it's extremely unlikely, but theoretically possible. Let's look at the real threats. The nearest known black hole to Earth is about 1,600 light-years away. That's incredibly far in human terms. For a black hole to threaten Earth, it would need to pass through our solar system, and space is so incredibly vast that the chances of this happening are astronomically small. Remember, black holes don't wander around sucking up everything like cosmic vacuum cleaners. They follow predictable orbits just like stars and planets. Scientists have mapped the movements of objects in our region of the galaxy, and there are no black holes on a collision course with us. But let's say one did somehow approach our solar system. The real danger wouldn't necessarily be getting sucked in. A black hole passing nearby could gravitationally disrupt planetary orbits, potentially ejecting Earth from the solar system or sending us crashing into the sun. Either scenario would be catastrophic, obviously. There's also the danger from supermassive black hole activity. If our galaxy's central black hole suddenly became very active, creating powerful jets of radiation, and if those jets pointed at Earth, the radiation could strip away our atmosphere. But again, this is incredibly unlikely given our position in the galaxy. Here's some perspective. Earth faces far more immediate cosmic threats than black holes. Asteroid impacts, solar flares, nearby supernovas, and gamma-ray bursts are all more likely to affect us in any reasonable time frame. The beautiful thing about astronomy is that we can actually see these threats coming. Scientists continuously monitor near-Earth objects and stellar activity. Black holes, despite being invisible themselves, affect their surroundings in ways we can detect with X-ray telescopes and gravitational wave observatories. In fact, black holes might have actually been important for life in the universe. Some scientists think the jets from supermassive black holes might help spread heavy elements necessary for planet formation and life. So should you lose sleep over black holes destroying Earth? Absolutely not. They're one of the most fascinating objects in our universe, laboratories for testing the limits of physics, but not an imminent threat to our planet. What we should feel is awe. Black holes prove that the universe is far stranger and more extreme than we ever imagined. They're cosmic monsters, sure, but they're also cosmic teachers, showing us just how wild reality can get. If you enjoyed diving deep into the science of black holes, make sure to hit that subscribe button. We've got more mind-blowing space content coming your way. What cosmic mystery should we explore next? Drop your suggestions in the comments below. Thanks for watching, and remember, stay curious about the universe.